Alright, but let's roll in this, alright guys? So on this, up here on top of the board, I put silicon dioxide for us to work through. Silicon dioxide. So in this, we're going to roll through. Well, first rule, find the center atom. It's the one with the lowest electronegativity, and it's never hydrogen. So in this case, it will be silicon, because it has lower electronegativity between silicon and oxygen. Step 2, draw the skeleton, give all atoms full octet when required. So we're going to draw a skeleton. We got 2 oxygen.
A skeleton?
No.
Never mind. So that's how you draw a skeleton?
You just draw. It's like the skeleton of the Lewis structure.
It's O dash that thing dash O.
It's all the atoms bonded together.
So but it'll always
Sometimes. It depends how many things you got bonded to. You'll see difference. Give everything a full octet. Remember, full octet, octet rule, everything wants to have 8 except for those 4 that break it. In this case, none of these break it, so we're fine. So we're looking at, they all want 8. This oxygen wants 8, but it has this bond here, which means it has 2. Which gives me 6. I need 6 electrons, and whenever we're given full octets, we do it in lone pairs. So we do it in pairs, like pairs of shoes on your feet. So we need 3 lone pairs, so there's 1, there's 2, there's 3.
8 minus 2. No, the bottom.
Where'd you get the 2 from?
6.
Here,
Under the no.
6, 12, 3.
Yeah.
I think the bottom.
that bond.
6, 12, 3.
That means 2.
The bond represents 2 electrons. Every bond will always, each bond represents 2
So will
electrons.
the first one always be 8 minus 2?
No.
I don't understand.
It's 8 because it's oxygen. Oxygen wants 8 electrons.
Oh,
Okay, then we got the 2 coming from that bond that's already there. It already has 2 electrons.
Well, why does only oxygen want 8?
They all want 8.
Yeah, that's what I thought. So
Wait.
wouldn't it always be 8 minus 2?
Unless hydrogen's there. Hydrogen's a rule breaker. It only makes 1 bond.
We don't like hydrogen.
Octet.
Actually, before I continue more ahead of you, is there a possible chance that there could be like 3 lines?
Yes.
Okay, well, and we gotta write all of the possible ways, so we'd have to write those 2.
There you go.
Yes and no.
no, that's okay. I don't think
You understand that, Trevor? Okay.
I can't even
Alright, let's go to silicon. Silicon wants how many electrons? How many electrons does the silicon have on it? 4.
Hold on.
She cracked it. She cracked her honey. She broke it.
So how many electrons does silicon have bonded to it?
8. Answer. Say it.
3.
I'm trying to help you here.
It looks like you read this.
Where do you get 4 from?
Is this that?
The bonds.
Oh.
So how many dashes?
There's 1 dash to the silicon, there's another dash to the silicon. There's 2 dashes, each dash represents 2 electrons, so 4. Sure you do. I got the need of 4 electrons, divided by 2, gives me 2, so 2 lone pairs, 1, 2.
Oh, wait, what?
The nurse in the ear today.
I have no clue.
Because that's what one we're on.
Oxygen wants how many electrons?
8.
How many does that oxygen have?
Can I ask you a question?
Tasha Harper, Tuesday, Wednesday to the office.
This time at the door.
Who?
I'll walk this down, please.
Alright, so it has 2, so 8 minus 2 is 6, needs 6 electrons, what we do in a lone pair, so 6 divided by 2 is 3, 3 lone pairs, just like the one before. 1, 2, 3.
Don't you have a Leah?
She's
Not here.
Okay. All right. I couldn't see her. I was going down the aisle trying to find.
You're
Thank
fine.
you.
Mr. Hall.
Yo,
We're going, are we on number 5?
no.
What, which one are we on? 2.
Right now we're still at 2.
We're still on number 2?
Yeah.
I've done all those.
I think I'm about had it with this.
I'm sorry.
You're fine. You don't have to look at this like this. Like you can roll through like you have. All right. In this case, we're done with step 2 now. Everything has full octet. Going to step 3. Calculate the number of electrons you must show. In this case, periodic table. We have silicon. We have oxygen. I have 1 silicon and 2 oxygens. Where did I get that from? And yes, I'm asking you that.
Because that's the number at
Well,
the.
silicon, you only got 1 up there. Then oxygen, you got that 2 representing there's 2 oxygen.
Thank
Yeah,
you.
0 squared. I was going to say that.
All right. In this case, how many valence electrons does every silicon have?
4.
4.
Why do you get 4?
Because Hunter said so. Because
Should I answer
there's
this
2
one?
bonds.
Yeah, go ahead.
Because it's in column 14.
And how many valence electrons
4.
are from column 14?
80. That's a joke. That's a joke.
All right, just out of curiosity, Hunter, keep your grabby hands down. How many valence electrons per oxygen?
6.
Why is it 6?
In the 6th column.
16th column.
16.
It's okay. We just 10 off.
1 times 4 is 4. 2 times 6.
12.
12. 4 plus 12.
16.
16.
75.
So you must show 16 electrons, and you can only show 16 electrons.
Wow.
Showing,
Yeah,
showing 4 too many.
periodic table on this?
Yeah, you have periodic table.
Okay.
We're showing 20.
We're gonna fix that.
Because
Why?
my periodic table has my.
You dropped it?
All right. So
I guess I'll invite.
how many electrons are we showing?
I thought we was done. I guess
Wait.
I'll handle it.
Too many. 20.
You are showing 20.
0, 2. Oh.
1, 2, 3, 4, 5, 6, 7, 8. The bonds count. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
So you erase
Take the subtract signs out.
You erase the thing.
Then you don't have a bond.
Mr. Hall, you take the slash, you put a slash in on it. No.
Add.
You
Should I
take
answer
two-
this?
Add double, triple bonds where needed to fix the number of electrons showing.
So
Resonance when applies. That's the last thing. We're not there yet.
Did you say?
All right, we need to add in double or triple bonds here. So in this case, we're going to start with the double bond.
You make it
Where do you want to put the double bond, on the left or the right?
It don't
You
matter.
can do both, actually.
You need to do that.
You can do a double bond on each side.
Okay, I know we can, but I want to show you something.
Show us.
Where are we going to stick first double bond?
You said left, I said on the right. Right.
Left.
Doesn't matter.
I just said
In
that.
the middle.
Right, sounds great. All right, so we stick the double bond here. In this case, remember, you have to take these lone pairs off. Every one of those atoms you've added that bond to. So in this case, you have to remove it from this oxygen, but do not forget silicon. If you do not take them off, you're breaking the octet. You cannot break the octet unless it is a rule breaker.
Does it
Oxygen's
matter
not a
which
rule
ones
breaker.
you take off, or do you have to do the ones?
No, as long as you just take them off. Like, if you would have took the top ones off, it'd been fine. All right, now how many electrons are we showing?
That's the secret key.
16.
18.
Why
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, because I count 18.
18?
Question.
What?
Is there another way you can figure that out, or do you have to count your dots? You gotta count dots.
Count by twos.
I mean, you could consider the fact that we were showing 20, we added 2, which makes us showing 22, and then we took away 4. So 22 minus 4 is 18. Or you just count.
I understand.
Alright, so we are still showing too many, so we need to add in another double or triple bond. Now you need to always shoot for symmetry. And I'm gonna show you how.
Can you not just take 2 off the other O?
You can't do that yet. Right?
You can't like just do this.
Yeah.
Does it have a full octet? Does it have a full octet? Keep thinking.
Can I spit it out? Or do you want them to think?
I want them to think.
Sorry, honey.
Sorry, science is just my thing. I'm
You
sorry.
put your line through it. I say for our lab tomorrow, we put Hunter's brain on his head.
No, we need him. Some of us aren't catching these.
Okay,
Okay, I'm not catching these.
would you do what you need to the other side? Like take off a pair and
I
then
wished I had
put
a
another
special
bond.
subject I was good
Is
at.
that all you do?
So put a bond there.
Take
And take one off.
And then take one off of the oxygen. Wait, that would, that's, no, because you'd have to,
You're right so far. Just continue.
You still get 18,
And
so
then
you
you
have
take
to take
one off
another
the
one off
silicone?
silicone, right?
That's not why you take it off silicon.
That's dirty.
Explain to me the reason as to why I'm going to erase those 2 electrons.
because it already has all.
Cause
Like,
they
with
make
the
it have
two
too many
bonds on
dots.
each side.
It's still,
I wanna
it's
explain
still
this.
an octet rule.
This is
It's what?
It's still octet rule.
Still octet rule.
It's not, it's
Octet
blanking.
rule.
Silicone has too many.
Structure guy, we'll fight.
Okay, silicon has too many, so
Everything to the
it's
left.
breaking
The ox-
My heart.
the octet rule. Thank you.
Huh, so we did all this
That's
for
what I
nothing?
said.
See, I thought,
That is not what you said. You said still octet rule. Like literally, I have it on camera. Still octet rule. You didn't even say like that. Wasn't even grammar.
hey Cameron, can you cut that?
I go through a different process that helps me through this also.
And now for a quick
There's more than
commercial.
one way to do it.
I just thought I was wrong.
All right. In this case,
Right there, Sam.
you mentally do this. You have been screaming at me to do this forever. You mentally do this. You do not physically do this.
Huh.
If you physically do this, you must give me this off by itself. This is the proper Lewis structure. Whenever you're going to step 6 and you're checking the charge, you must mentally do this. Split the bonds in half.
So you don't really do it.
You do not. Because if you give me that as the Lewis structure, you're wrong.
So we might as well just
I
not
wish we
include
were
it then,
doing orbital spin.
right?
They come off to the side.
So we have to put the dots.
You don't have to. This is mental. I'm showing you physically what you should be doing mentally. Because we're going to check these charges. When we check these charges, you refer it back off to the valence electrons that they started with. Oxygen starts with 6 valence electrons. I know that because of what?
The 16th column.
16th column. 16th column has 6 valence electrons. Minus how many electrons are showing now. 1, 2, 3, 4, 5, 6. So 0. That oxygen's neutral. Silicon. How many valence electrons does silicon normally have? 4 minus 4, because I'm showing 4 now. 1, 2, 3, 4. 0, neutral. Awesome. Let's go to this last oxygen. Oxygen normally has 6. How many does it have right now? Showing 6. 1, 2, 3, 4, 5, 6. 0, neutral. So they're all neutral all the way through. That's great. That is not a properly drawn Lewis structure. So I must redraw it.
Is this the part where you do like the equal sign thing?
So we
No.
So for something like this, we don't have to do the triple one. We just try to keep it stable like this. Then
That's it.
okay.
For the triple one, I'll give you one for the triple one.
Okay.
All right. How y'all feel?
Bad.
Wait, you know how I feel?
Real bad.
I feel pretty good.
Like I need to go.
This is not hard if you're paying attention and not like on a phone or sitting there and messing with a model.
Tiny.
It's a hiney.
Help on.
His face It's a hymen.
No,
So
it's not.
that's all we gotta put? Yes.
Just shh.
Are we gonna add another one?
Never mind. They're gonna get us.
Yeah.
Is this gonna be the one with the triple bond?
Pretty old.
Hydrogen cyanide.
C.
Huh?
Hydrogen, carbon, and nitrogen.
Hydrogen cyanide.
That's a deadly gas, ain't it?
Is that carbon?
In the middle, it's carbon.
Is it a deadly gas?
It's not a gas.
Oh.
Okay.
Is it air? So how do you know?
Look at it.
Well, these
Lowest electronegative. What's the lowest electronegative?
The one with the lines.
well, hydrogen is an octet thing. Right there.
Never hydrogen.
So C.
Cyanide.
Okay, why C?
It's in the middle.
Oh, I've seen this on
Okay.
the board of anatomy.
Actually, you did not see that.
Oh, dang it.
That's something different. Carbon is the center atom. Why? It has the lowest electronegativity between carbon and nitrogen.
Oh, so carbon could be before. It's not always in the middle, right? Or is it
True,
always?
but normally you're going to see carbon in the middle.
So you just look on the periodic table and whatever number is.
Yeah, you can press the electronegativity number.
Hey, wait.
Well, let's make sure we understand.
1.1.
The electronegativity number. We're not comparing any other number on here besides this electronegativity number.
So 2.5?
2.5 is carbon, 3.0 is nitrogen.
HC.
Make sure we got that. The electronegative number, not the atomic number. Not the average atomic mass. 80.
N.
Alright, let's draw a skeleton.
N.
We don't like these skeletons.
Give everything a full octet where required. How many lone pairs for hydrogen?
8.
How many?
8.
8 lone pairs for hydrogen?
Because it's a trick.
1.
1 lone pair for hydrogen?
2.1.
It only makes one bond. So I don't know.
It only will make 1 bond, so
I was like,
you're right, it's a trick. There is no lone pairs on hydrogen.
So I said 1. That was wrong.
Yes.
Love that.
It only makes one bond. I knew that.
How many lone pairs for carbon?
8.
He stared at me just.
6.
Here's the hole. It wants 8. 4.
It wants 8. How many lone pairs?
4.
I can't even see that.
Wants 8, has 4, wants 4 electrons. How many lone pairs?
2. Wait, so you don't do
Thank you.
anything for H? Any of these
No.
letters?
No, because
We don't do-
hydrogen only makes one bond. So it's a trick. Wait.
Hydrogen is an octet breaker.
Alright, but what if we have one
Oh, okay.
form like 3 bonds?
Like boron?
Yep.
Then it'll form 3 bonds.
So y'all put 3
One's
bonds?
8 electrons.
No,
Are they
that's
up there?
electrons.
Yeah. You get how many
Nitrogen.
electrons from up there?
How many lone pairs?
8.
He says 8, Christina.
I don't even see nitrogen.
Christy, let's
Wait.
talk about they
5.
nitrogen wants 8. Okay, that's not how many lone pairs we give it.
5. Maybe.
I don't even see
This one has a
nitrogen.
It
trick,
says
doesn't
5.
5. Is this one?
Nitrogen's atomic number 7. 15th column.
5.
I've been saying that for 20 minutes.
He said it once. I said it
5.
How many lone pairs for the
Is
nitrogen?
this a trick? Is this?
No, this is not a trick.
5. It wants 8.
Before I
Subtract 5.
get drunk crazy, let me see if I got this right.
Oh my god.
Hunter, just
Wants 8.
Yeah, one.
Whoever said it.
Minus
And
5.
then
Over here.
subtract 5.
No.
Oh,
Okay.
Lord.
Didn't think so.
How many does nitrogen have?
5.
Well, apparently not. Because he
5.
Thank you. 2.
I see. You wasn't.
There's a bond right there.
Oh, you asked.
I'm gonna cry.
I asked how many lone pairs, and everybody keeps screaming 5. So then I asked how many electrons does it have,
Because the multi-grid.
and everybody still wants to scream 5.
So why wouldn't you subtract 5?
This is different. You're building the structure. You're not on the periodic table. We're not there. You're building the structure. When you're given the full octet, you look here. Has 2, needs 6. Lone pairs comes in groups of 2
3.
to 3.
At least we know that much.
We think we know that much.
Oh, okay, I get the dots now.
Thank God. We have now given everything full octet. You now go to step 3 and you calculate the number of electrons you must show, and this is where you're going to use the periodic table. We have hydrogen, carbon, and nitrogen. We have 1 of each.
Hold on. We need 3.
How many valence electrons per hydrogen?
How many what?
1 valence electrons per hydrogen. How many valence electrons per carbon? 4. How many valence electrons per nitrogen?
5. Finally, my answer.
So you get 1, 4, and 5. You add those together, it gives you 10. So you must show and only show 10 electrons.
We have too many.
Don't erase that.
All right. How many are we showing?
14.
14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Gotta go 10.
What do you got to do to fix it?
Take 2 away. Erase 4.
Add a double bond.
Equal sign.
Double bond.
Dang.
All right, where are we going to put the double bond? You going to put it on the left or the right?
Right.
Right? Why not the left?
You don't have any
Just
extra
like
electrons
Not
over
gonna
there.
take away.
Don't have any extras over there, but will hydrogen form double bonds?
No.
No. That's why.
Put it on the next one.
Because we don't like the left.
I'm looking.
All right. What do I do from here? Walk me through it.
You erase. Take off.
Nitrogen.
Right.
Take off 1 nitrogen.
Erase
Take off
2.
a pair. Yeah.
1 nitrogen and 1 carbon.
Good job.
Done?
Wait.
You wrong.
3, 4, 6, 8, 10, 12. We're still showing 14.
Yeah, you take off another one.
You took off the nitrogen. What else do you take off of?
Carbon.
And then add
I
another
said
double.
that.
Yeah, she said it earlier.
We don't care.
That's what.
We don't listen to them.
All right. So we're showing 12. So how are we going to fix it?
Take out the equal sign.
Put another equal
No.
sign.
Take off one of the
That's completely
nitrogen.
breaking
Put
the
another
bond.
equal sign.
Triple. Oh, not again.
Add double, triple bonds where needed. Can I throw a double bond here?
Yes.
No. Hydrogen's sitting there. Hydrogen forms 1 bond.
So would you add another one?
Are you with us today, Christy? Like,
Can you add another line on top of it?
Triple bond.
Equal sign.
or a triple bond.
There you go.
2, 4, 6, 8, 10, 12.
So what do I got to do from here?
Take another 1 off of nitrogen.
Take another 1 off?
No, 2. That's not.
Take a pair off.
Oh, a lone pair. Sorry. Okay, we done?
No.
Why? What about carbon?
You gotta take a pair.
Gotta take one off the C.
Take 1 off C?
Take the lone pair off of C, Mr. Hall.
Take a lone pair off. We done?
6, 7,
No,
8.
2, 4, 6, 8, 10.
Yeah.
Yes, we are done.
Done.
I thought he was gonna put a big
So
X.
we
I was
don't
like,
have
are you
to-
joking?
What do you do? Do the symmetry thing?
In some cases, you can. In this case, you literally cannot do the symmetry.
And why is
Hydrogen only forms one bond.
Okay, so just.
Yeah, I was right the first time I wrote it down, but then I questioned myself, and that's when I got it wrong.
Alright.
Yeah, I wish somebody would you.
There comes a time in life to where things are just too simple.
Yeah.
What about the other part?
If you make this harder, I'll make right.
Like,
Everything was neutral, my bad.
Give us a good one, like a.
It's a good idea.
No.
Okay, show
Let
me.
me introduce you to one of my dearest friends.
Married?
Hold on.
He picks up from girls.
So CO3. CO3 is carbon trioxide. But everything changes once we do this. And we put 2 negative. Once we put the 2 negative there, we have changed from carbon trioxide, and now we are dealing with carbonate, which you will find out tomorrow is one of your common polyatomics.
Ain't that, like being like all serious, isn't that like all?
No,
Isn't that when it loses like 2 electrons?
no.
Okay, well,
It sounds like.
So this is the thing.
Derek Brown to the office, Derek Brown.
Dead giveaway, I'm trying to trick you.
Wow.
I've given you a charge.
Wait, so that means that's a joke, right? Or a trick? It means
Big one,
this
he's
is
trying
why.
to trick us. That one's
Trick.
trick, 2 negative.
I'm going to show you how to handle the trick.
Oh man. Just erase.
It can't be on the.
Follow every step as you follow. And here at step 3, we're going to take care of that charge. Step 1.
Eraser.
It's the easiest place to handle it. Step 1. Find the center atom. What's the center atom?
Carbon.
Why is it carbon?
Cause oxygen is.
It has the less
This is the one I saw.
electronegativity.
Lowest electronegativity.
What do you mean?
Jolly Rancher.
Chicken nugget.
Step 2. Draw a skeleton. Give all atoms full octet when required. So let's draw the skeleton.
What?
Oh, where it's a negative, isn't it? Oh, it's where it's 3 of them. I forgot.
Okay.
I'm the. My brain is
I was doing this right before.
Guys,
I wrote,
like,
so,
I got you. Let's go.
give everything full octet. How many lone pairs for the oxygens? 3. Why 3? They all have a bond to it, which means they need 6 electrons, which means
You
3
pair
lone
your
pairs.
pair.
This is cute, kind of.
Carbon? How many lone pairs?
2,
2. Wait, no.
3.
1.
Hey.
1. Oh, God.
Wait, carbon?
1.
Huh.
It has 3 bonds.
That's ridiculous.
Three bonds. How did that give you one?
Bond, bond, bond.
1, 2, they're 2.
It sounds like one.
1, 2, 3.
Nemo. Mine.
For a correct answer, wouldn't we have to end up writing it 3 different times? Practically?
You will.
Okay, I thought so.
Alright, in this.
What are you talking about?
Step 3, calculate the number of electrons that must be shown. So in this case, we got carbon and we have oxygen. How many carbons?
1.
How many valence electrons per carbon?
1. Wait, just no. Don't listen to me.
4. How many oxygens?
6.
How many oxygens?
3.
Okay, yeah.
Oh, 3.
3.
Big words.
How many valence electrons per oxygen?
6.
6.
I'm really so mad right now. I'm sorry.
Okay, I'm sitting beside him. Want me to take this?
So 4 plus 18, 22. This is where you take the charge into account. This spot right here. You look whether you have gained or lost electrons. The charge will tell you. It's negative. What are electrons? They are negatively charged subatomic particles. So if I have more negative charge, I've gained electrons.
Is that 22 or 52?
What did you put?
Add to.
Why?
You gain
There's a
electrons.
But there's a minus.
Because electrons are negatively charged.
So you have to do the opposite. So how would you know if it's
Sure.
a subtract? If it didn't have the minus sign up there?
Yeah, first
Then
plus
it
the
said
sign.
2.
So if it said 2, you would have to do like the.
Alright, so we must show 24 electrons.
Mr. Hall,
Yeah.
I can't see that. Did you just added that 2 to the 2, right?
Yes.
Time to
Banana!
Thank
Say Mama Bell.
you. Come on now.
Tomorrow we will pick up on this and we will pick up on those polyatomics. I'm going to finish this just for video's sake, since we're right here. So we can only show 24 electrons. You count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Showing 26, we're showing too many. So we got to throw in
Miss
a double
Bridget
bond.
Walker, 6, please come to the cafeteria and sit in front of the office.
So in this case, let's throw a double bond in right there. You take the lone pairs off where you added the double bond. Added a double bond here and there. So we remove from those.
Then you'd have to end up writing it 3 different times.
But you must also keep in mind, check for charges. Because whenever you look at it, look at this oxygen. You're going to split that bond in half, mentally thinking about it, split it in half, electrons split to the sides. This oxygen starts with 6 valence electrons, and in this case it's showing 6 valence electrons. So 0, it's neutral. But these two oxygens start with 6,
Yeah.
split that bond, we're showing 7. 1, 2, 3, 4, 5, 6, 7. So, -1. That has a negative charge, and that has a negative charge. And you'll find out the carbon's neutral because carbon normally starts with 4, and it's showing 4. So in that case, 0. So there is the first part.
So the only thing I didn't do was show the negative charges.
And then in here we can throw different spots where we can throw that double bond. So we have resonance structures. Bye. And the last one. And there is your properly drawn Lewis structure for carbon.